Hello everyone, Namaste. Hope you are all doing well. Welcome to Vivid Academy. In this video, we will be discussing the effective nuclear charge and Slater's rules using which you can determine the effective nuclear charge of an electron in a given atom. So we all know that the electrons which are present in an atom, it experiences an attractive force by the nucleus. So because the nucleus is positively charged and electrons are negatively charged. So this attractive force that is experienced by the electrons towards the nucleus is what we call as the nuclear charge, and it is represented by Z. Now we have studied this shielding effect or screening effect. Because of this shielding of inner electrons on the outer electrons, the valence shell electrons experiences a lesser attractive pull from the nucleus. As a result, the effective nuclear charge that is experienced by the electron present in the valence shell decreases. So this decrease in the nuclear charge is what we call as the effective nuclear charge. So you know, shielding effect or screening effect is nothing but it is the decrease in the effective nuclear charge that is experienced by the valence electron because of the shielding of inner shell electrons. Now because of this screening effect, the nuclear charge that is experienced by the valence shell electron is decreased, and that decrease that is observed in the nuclear charge is what is called as effective nuclear charge. We all know that the nuclear charge is represented as Z, and the effective nuclear charge we represent it as Z star. And the mathematical expression for the effective nuclear charge is written as Z star is equal to, which is the effective nuclear charge, that is equal to Z minus sigma, where you know Z is the atomic number. Now sigma is called as the screening constant. Sigma is screening constant, or it is equal to the number of shielding electrons. It is equal to the number of shielding electrons. So now we have the effective nuclear charge Z star is equal to Z, the actual nuclear charge, minus sigma, which is the screening constant, or it is equal to the number of shielding electrons. In order to calculate the value of effective nuclear charge, you need to know the nuclear charge and the value of screening constant sigma. The actual nuclear charge is nothing but the atomic number, and sigma is the screening constant which can be calculated from Slater's rules. Now, you know, if there are more number of inner shell electrons, then the screening effect will be more, right? More the number of inner shell electrons, more the number of inner shell electrons, greater is the screening effect. Greater is the screening effect. So what will happen to the screening constant? Screening constant Z will also increase if inner shell electrons increases. Screening constant sigma increases if the inner shell electrons increases. Then what will happen to Z star? Z star will decrease. So that is what is given in this point. Greater is the number of electrons intervening between the nucleus and the outer electrons, more will be the magnitude of screening constant, and hence magnitude of effective nuclear charge, that is Z star, will decrease. Now let us see how we can calculate the screening constant using Slater's rule, and we'll calculate the effective nuclear charge also. In step 1, we will be writing the electronic configuration of the atom by grouping them. Where first 1 is electron, we will write it as one group. 2s and 2p electron will be grouped together. 3s, 3p will be grouped together. 3d as one group. 4s, 4p as one group. 4d as one group. 4f as one group. 5s, 5p as one group, and it continues like that. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, and so on. In the next step, we will be identifying the electron of interest. It means that in the question they will be giving us for which electron we have to identify. We have to calculate the effective nuclear charge. So that electron we will identify and ignore other electrons which are present in the higher group. Okay. So those electrons will not shield the electrons in the lower group, so that we will be neglecting the higher groups. So this will be more clear when we consider an example. Okay. So now in this step 3, this rule is now has to be broken into 2 different cases. Now let us consider that. The shielding experienced by an S or P electron. Okay. So now we are considering 2 different cases. One is where the shielding that is experienced by S or P electron. And in the second case, we will be considering the shielding that is experienced by ND or NF valence electrons. So this is very important. First 2 steps are common, and this step 3 is very important. Now, firstly, let us consider the shielding that is experienced by S or P electrons. Now, when we calculate the shielding experienced by S or P electron, we will consider the electrons within the same group, they shield 0.35 except the 1s. If we have 1s electron, then the shielding is considered as 0.30. Electrons within the same group, their shielding is considered as 0.35. If it is 1s, then the shielding is considered as 0.30. Now, if the electrons are within the n-1 group, then shielding is considered as 0.85. And the electrons within n-2 or lower groups, then the shielding is considered as 1. Now, in the second case, we are going to consider the shielding that is experienced by ND or NF valence electron. So, if we have valence shell in the d orbital or f orbital, electrons within the same group, they shield 0.35, and the electrons within the lower group, if it is n-1, n-2 and so on, whatever the lower group it is, then the shielding is 1. Firstly, we will be grouping the electrons 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, so on. Then we will identify for which electron we have to calculate the effective nuclear charge, and we will be ignoring all the electrons that is present in the higher group. Then we will consider 2 rules, that if we are going to calculate the shielding for S or P electron. In case it is S or P electron, electrons which are present within the same group, then the shielding is 0.35. If it is 1s electron, then the shielding is 0.30. Electrons within n-1 group will be contributing a shielding of 0.85, and within n-2, the shielding is 1. In case of the valence electron, if they are belonging to ND or NF orbital, Electrons within the same group shield 0.35 and within the lower group shield 1. Now let us consider examples so that calculation of effective nuclear charge will be more clear. Now the question is to calculate the effective charge experienced by a 2p electron in the nitrogen atom. So first of all, let us write the electronic configuration for nitrogen atom. We know nitrogen atom has 7 electron. Electronic configuration is written as 1s2, 2s2, 2p3. Now in step 1, we have to group the electrons, right? So 1s is one group, so this is 1s2, 2s, 2p in one group, 2s2, 2p3. Now we have to identify the electron of our interest, right? So here they have asked to calculate the charge that is experienced by a 2p electron. So we have the valence shell here, that itself is the p. Okay, we will be finding it for the 1 electron of p orbital. Other than that, we have 4 electrons in the second shell. Okay, so now we need to find out sigma for a 2p electron. Now let us calculate. Okay, so now this is the nth orbital and this is n minus 1. Now other than the 1 electron which we are considering, we have 4 electrons in the nth orbit, and in n minus 1 we have 2 electrons. So now we have to consider the first case of step 3, since we are discussing for the 2p, we are discussing for the p electrons. Okay, s or p, the rules are same, and other electrons which are present in the same orbit contribute 0.35. How many electrons we have other than the electron of interest? It is 4. Then coming to the n minus 1 orbit. Okay, so they contribute, or their screening or shielding is considered as 0.85. So how many electrons contribute 0.85? It is 2. So we have 0.85 into 2 plus 0.35 into 4. So 2 into 5 is 10. 8 2 is 16 plus 1 17. 2 into 0, 0.70, 20, 1.40. When we add up, we get 3.10. So the screening constant for a 2p electron of nitrogen is 3.10. So in order to calculate the effective nuclear charge, we have Z star is equal to Z minus sigma. The value of Z is 7. Z minus sigma is 3.10. 7 minus 3.10, it comes out to be 3.90. So this is the effective nuclear charge that is experienced by the 2p electron in the nitrogen atom. Let us consider another example to be more clear. Now the question is, what is the shielding constant experienced by a 3d electron in the bromine atom? Here they have asked us to find the shielding constant. Okay, we are not going to find the effective nuclear charge. We will just stop at the stage of calculating the shielding constant experienced by a 3d electron in the bromine atom. So the atom is bromine. Atomic number is 35. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. And this is how we write the electronic configuration of bromine. Now let us group the electron according to the step 1 that we have studied. So the first group is 1s2, 2s2, 2p6, 3s2, 3p6. Next we have 3d10. The next shell we have 4s2, 4p5. So grouping is done. So now here we are supposed to consider one of the 3D electron. So from the 3D, one we have to consider. So we can neglect the 4s and 4p electron because they are not going to contribute to the shielding electron. So they do not contribute to the shielding constant sigma. So we are going to neglect it. So we are going to consider one of the 3D electron. So remaining we have 9 electrons. And in the inner shell, when you consider the when you are going to calculate the shielding constant for a D or F valence electron, the contribution from all the inner shell is considered as 1. Okay. So here we have 18 electrons. So now let us calculate the shielding constant for 3D electron here. We have 18 inner electron and their contribution is 1.0, right? 1.0 into 18 plus we have 9 electrons in the d orbital and they contribute 0.35. So we have 18 into 1.0 is 18.0 plus 3.15. So now 18 plus 3.15 is 21.15. So this is the screening constant that is experienced by the d electron in bromine atom. Now if you want to calculate the effective nuclear charge, you can calculate Z star is Z minus sigma for this d electron. So Z is 35 minus sigma is 21.15. This is equal to 13.85. So the effective nuclear charge that is experienced by the d electron in bromine atom is 13.85. So I hope now you can easily calculate the shielding constant for an electron as well as the effective nuclear charge that is experienced by an electron. I hope you have understood the concept of effective nuclear charge and Slater's rules using which you can determine the screening constant and hence you can calculate the effective nuclear charge of an electron in a given atom. Thank you for watching. Stay connected. Keep learning. Take care. Bye-bye.